we will see about another undecidable non-computational problem. It is called the post-correspondence problem, or PCP. Okay. Now, why is it called post? It was actually introduced in 1946 by a computer scientist called Emil Post. The picture you see on the right is Emil Post. Okay. So he was the person who came out with a problem called correspondence problem. And he argued that this particular problem comes under the category of non-computational or undecidable problem. Now, this is actually a very interesting game. More than a problem, it is a game where you have to arrange dominoes. Okay, if you look onto the screen below, you can find four blocks over here. 4 blocks or 4 tiles. Each of this, you call it to be a domino. Now, I'll just name this my first domino, my second domino, this is my third, and this is my fourth domino. Now, each domino, it will be having a top portion or the numerator, and it will even have a denominator or the bottom portion. Now, what the problem is, it is very interesting. Arrange the dominoes. Arrange the dominoes in whichever pattern you want. It need not be 1, 2, 3, 4. Arrange it in whichever order you want. Have how many ever repetitions you want. But the numerator and the denominator, they should be in the same sequence. Like, if in the denominator you have A, B, C, even in the numerator, if you have A, B, C, even in the denominator, you should be having A, B, C or whatever. Okay. So the numerator and the denominator should be the same. So the question is, are you able to find a finite sequence? This is very important. Finite, with correct number of, with a particular number of dominoes, will you be able to find out a pattern where the numerator and the denominator will be the same? Okay, so let's try to play this game. Okay, so we'll
a referendum is a voting conducted for the
try solving it.
Parliament.
Okay. So now we have got 4 dominoes, 1, 2, 3, and 4. Now let's try solving it. Okay. As I told you, the top portion and the bottom portion should be the same. So it is very simple. It is a trial and error method, and you should be able to tell at the end of the day, will you be able to find out a generalized algorithm which will give you an answer, yes or no? Are you able to solve it? Are you not able to solve it? Okay, so let's see over here. B, top, bottom, I have CA. The first terms, they will not be equal. Okay, look here, A, AB. Okay, so which means, first term I can assure of it. So very simple, when you're playing dominoes, the first tile will always be the tile which has the numerator and the denominator as same. Okay, so here I will be having A, AB. Okay, so that is my first tile. Okay, so I'll have it in my sequence. I will have that's not my first tile, that is my tile number 2. Okay, I have my tile number 2. Next, on top, I need B. On top, I need B. So I have to find out a tile which has numerator B. Okay, so I have only one tile over here which has numerator B. So I will write B over here and then CA. Okay, so now I took the second tile. Okay, so this much part is okay. AB, AB. Okay, now next I need a tile which has something starting with CA on the numerator. Okay, so that is my third tile, CA. So I take CA divided by A. So that is my third tile. Okay, CA, CA. Okay, so till here it is fine. A, B, C, A. That looks good. And then A, B, C, A. That also looks good. Okay, now what do I want? I want an A in the numerator. I want the A in the numerator. Look here, A in the numerator. I have two things, A, B, C. Trial and error method. I'll go for the first one first. So I'll write A over here, and then I will have A, B over here. Okay, so check A, B, C, A. That is clear. A, B, C, A. This is also clear. Now, what do I want next? I want something which has AB in the numerator. I want something which, yeah. So it means I'll be taking ABC. I will be taking ABC, C. Oh, perfect. ABC, C. In between, I forgot to write down the pattern. It was 2, 1, 3. A by AB is 2. And then I have 4. Okay, which means, very good. I was able to come out with the solution. I was able to come out with the solution for this particular dominoes. I was able to solve it. Finite number of steps. 1, 2, 3, 4, 5. 5 number of steps. I was able to solve this particular dominoes problem. Now let's another PCP problem. Okay. So now, I don't write it in the dominoes representation. Instead, I'm writing it in a list, a tabular kind of representation where, A is nothing but the numerator and B is nothing but the denominator. Okay. So this is my first tile. I'll not write the numbers. It looks a bit awkward. Okay. This is my first tile. First tile, actually, it is, 1 by 111. This is my first tile. My second tile is 1, 0, 111 by 1, 0. And my third tile is 1, 0 by 0. So these are my dominoes. My first denominator, numerator is 1, denominator is 111. And then this particular domino, and then this particular domino. The question is the same. Try arranging it in a finite sequence such that the numerator and the denominator is the same. Okay, so let's check. First thing, 1, 1. You can either take this or you can take this. 1, 0, 1, 0. You can take this or this. Anyway, this you cannot take because, 1 and then the denominator is 0, which means, initial step itself, you will not get it equal. Okay, so we'll go random. Okay, I'll take the second one. Let's say, take whichever you want. 1, 0, 111 by 1, 0. So this part is satisfied, and even this part is satisfied. So which tile did I take? I took the second tile. Okay, now I need a 111. I need a 111 in the numerator. I need a 111 in the I need a 111 in the denominator, right? I need a 111 in the denominator. Check here. So this is fine. Okay, so I write here 1 by 111. Okay, so that is satisfied. 111 in the denominator. So that is satisfied. So which tile did I take? After this, I took my first tile. Now I do have a 1 left on top. Okay, which means I need something below which has a 1. You can either go for this or you can go for this, anything. So I'll just go for the first one. I'll give 1 divided by 111. Okay, so these two ones, they are satisfied. These two ones, this is also satisfied. Now I need something which has a 1 on the numerator. You can either go for this, or this, anything. Okay, we'll go for this. This is easier, right? You give 1, 0 on top, you get a 0 below, like, everything becomes equal. So, I went for my second tile, then I went for my first tile, after which again I went for my first tile, And at the end, I went for my third tile, which means I was able to find out a solution in finite steps. So the first problem and the second problem, you were able to find out solutions in finite steps. Third problem. Okay. So as usual, A is nothing but A is our numerator. B is the denominator, and then the usual things. Okay. So let's start solving this problem. Okay. So you have to go for something which has both numerator and denominator equal. So this is 1 0 1 0. You can go for that. Can you go for this? No, 0 1. You cannot go for this. So that is the only option. Third one also you can't. It is 1 0 0 1. So you'll have to go for this 1 0 by 1 0 1, which means my first one. Okay, I took my first tile. Now till here it is okay. 1 0 is fine, and 1 0 is fine. Now you need something which has 1 in the numerator. You need something which has 1 in the numerator. 1 in the numerator. You can either go for this or this. I'll just go for the first one. 1 0 divided by 1 0 1. Okay. So now look here. 1 0 1. This is satisfied. 1 0 1. This is satisfied. 1 0 1. This is satisfied. Okay. Now look here. I'm having a problem over here. Numerator 0, denominator 1, which means, very simple. I cannot take this particular tile. The first tile I cannot take. I should be going for some other tile because, the pattern is having a problem. So which is the next option? Anyway, this you cannot go. This you cannot go because, the numerator, you do not have a 1. So the only option is I go for the third one, 1 0 1 divided by 1 0 1 divided by. Okay, so this much portion is okay. This portion is also okay. 0 1 0 1. Is it fine till here? Is it fine?
Yes, ma'am.
Yes, ma'am.
So now till here it is fine. I have 1 in my denominator, which means, I should go for something which has a 1 on the numerator. I'll just go for the first one. I'll go for 1 0 by 1 0 1. Okay, so 1 is satisfied, but here I'm having a problem. 0 1. Very simple. My pattern will have a problem. So which means, I cannot take this tile. The only option is I go for 1 0 1 divided by 0 1 1. Okay, so I took my third tile, 1 0 1 by, so let's see, 1 0 1 0 1 till here, okay, 1 0 okay, 1 0 okay. So till here things are fine. 1 0 1 till here things are fine, except for the last one, everything else is okay. Okay, except for this, everything else is okay, except for my last one. Okay, my last one got into red, but that is a pending one. Okay, 1 0 1 0 1 1 0 1 1 0 1 0 1. Okay, so till here. So I do have something 1. 1 means what will I do? As you all know, the first one we cannot take. So we go for the next one. The third one, 101 divided by 011. Okay, which means, this one is also done. 01, yeah. And this 01, okay, which means, I have again a 1 remaining. Earlier cases, we saw that, you cannot take the first one, which means, you'll go for 101 divided by 011. If you go on doing it, it will be repetitive. It will be repetitive. You have a pattern like this: 1, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. You cannot find a sequence. You will not be able to find a sequence, or you say you will not be able to find a solution. You know how to do it. You have a procedure, but you cannot come to a generalized algorithm when you do the dominoes game. So what he told us, when you do the post correspondence problem, you will reach a case where you will not be able to find a generalized algorithm for this particular problem. Thus, this problem, you say it falls under the category of undecidable or non-computational problem.